Hello Math 1093, this is Reading the Sines. In this video we're going to talk about using trigonometric functions and trigonometric function values to find the measure of an angle in a triangle. So this is going to seem a little bit disembodied from any context because we are going to assume in this video that A is always the measure of an angle in a triangle. But I'm probably not going to draw a single triangle in this video. I'm just going to talk about one particular trigonometry / algebra move that we're going to use pretty often when we solve trigonometry problems, when we solve angle measurement problems about triangles. So in this video I want to talk about a couple of different scenarios. So the first one is, suppose I give you the following information, that the sine of A is 0.563, and I just made up the number 0.563, just totally random, okay? Because this is something that could happen if we are solving a triangle measurement problem, is we might use some trigonometric law or rule and figure out that the sine of a certain angle, or the sine of a certain angle measure rather, is 0.563, totally random number. And we might wonder, what is the value of A? That is, what is the measure A? What is the value of A? Okay, so one thing I want to recall here, just as a way of reminding ourselves how we approach problems like this, is this sentence here, that the sine of A is 0.563, we can interpret this in terms of function machines. So we have this function machine called sine, and we feed an angle measure, A, into the machine, and out comes the number 0.563. And because we define sine and cosine on the unit circle, this means something about what would happen if we embedded this angle A in a unit circle, and out would come a y-coordinate of 0.563. But we don't really have to think about all of that context here. What I want to do here, though, is think about, well, if I know that the output of the function is 0.563, how do I come up with the value of A? All right, well, remember that we have a sort of pseudo-inverse function, pseudo meaning fake. It's not really the inverse function of the sine function, but it's kind of like an inverse. So we have this thing called sine inverse that will take that output, 0.563, and it will return the correct value of A, or rather, a correct value of A. This will give us one possible value of A. Okay, so in other words, I can say that the inverse sine of 0.563 gives one possible value of A. And now I'm going to use a calculator to find out what the value is. So I'm going to punch into my calculator. I actually use Bing on Windows for this. It just gives you an idea of the level of sophistication I'm working with. So I just type into Bing arcsine of 0.563, and then I type the word in degrees in order to tell it to give me something in degrees. And it gives me a measure of 34.3 degrees. So that value is 34.3 degrees. It's rounded off to the nearest tenth of a degree. Okay, so that's one possible value of A. But this is only one possible value, and there is at least one more. Okay, so there's at least one more. And for this, to figure this out, I'm actually going to use a picture of the unit circle. So I'm going to draw my unit circle. Now see, I keep doing this thing that's strategically kind of foolish. I've always been taught that if you really want to impress people, you should draw the circle first and then draw the axes, because sometimes you draw the circle off center. But actually there I did a pretty good job, so I'll stop complaining. Anyway, so in this circle, I'm going to draw an angle of 34.3 degrees in measure. So that's about that angle there, 34.3 degrees. Okay. And then the point at the end of this has coordinates, some x coordinate, which I'm leaving off, and then sine of 34.3 degrees. That's the y coordinate. Okay. But now there is another place where I get the same y coordinate. That other place is over here on the opposite side in quadrant 2. And it's 34.3 degrees away from the negative x-axis, or the negative horizontal axis. Okay, so what is this angle measure here? That angle measure is 34.3 degrees. That's no mystery there. But what angle measure is this? Because that's what this is actually going to be the sine of here. That angle measure is going to be 180 degrees minus 34.3 degrees, which comes out to, now this I can do mentally, 180 minus 34.3 Let's put degree symbols on those. That comes out to, I believe, 145.7. Check my arithmetic on that, but I think that's what that will come out to, 145.7 degrees. So that means sine of 145.7 degrees, I'm going to draw that on this picture here. This is some x-coordinate, which is the opposite of the other x-coordinate, and then the y-coordinate is sine of 145.7 degrees. So that means that these two y-coordinates are the exact same, which means that the sine of 145.7 degrees is the same as the sine of 34.3 degrees. And we said earlier the sine of 34.3 degrees, that is 0.563. Check my work on that. Actually use a calculator. Check that the sine of 34.3 degrees is 0.563. But so is the sine of 145.7 degrees. That is also 0.563. Okay, so moral of the story here, I feel like I'm kind of circumnavigating the main point here. So the moral of the story is this equation has multiple solutions. And this is not even taking into account that I could add full rotations to each of these angles. But remember, I said that A was an angle in a triangle. A could be 34.3 degrees, or it could be 145.7 degrees. Okay, and both of those are viable solutions if I'm talking about a triangle. A triangle could very well have a 145.7 degree angle. It just wouldn't happen in a right triangle. But the problems that we're going to be solving at this point, they are going to involve some right triangles and some non-right triangles. So I want you to always be aware that when I see this equation here, there's always a couple of possibilities. We could have an acute angle, we could have an obtuse angle. All right, so here's another case I want to talk about. We might also end up in a situation like this where we get sine of A equals, I don't know, 1.289. Now, if we use the same strategy to try and find one possible value of A, so I'm going to write possible value of A equals arc sine of 1.289. I'm going to try running that through my calculator here. My little, actually it's Cortana, not Bing. I'm just using my little Windows interface here. So I'm going to say arc sine. Really, I should probably get some kickbacks from Microsoft for using their this is like a product placement. Arc sine of 1.289 in degrees. What is it going to tell me? Actually, this is kind of funny. Cortana is not telling me anything because it doesn't know how to find arc sine of 1.289 in degrees. But there's a pretty good reason for that. This number is not defined. And when you think about it, that makes sense. If I look at this equation here, it's never possible to take the sine of an angle, certainly not an angle in a triangle, really not any angle in this course, and get 1.289. This is an impossible situation. And yet, we may solve a couple of triangle problems where I give you some measurements and I say, could these be measurements of a triangle? And you use some trigonometric rule and you get sine of A equals 1.289. That means that once you get here, you can say, look, this is impossible. This cannot be a triangle. So I just want you to know that possibility is there. Okay, one other case I want to talk about, and that is what if we're given the cosine of some angle. So let's say that the cosine of A is known to be, I don't know, let's say a negative 0.341. I don't know why I need the extra decimal place. Just always include 3 significant figures and everything. Anyway, cosine of A is negative 0.341. First of all, is this even possible? Is this possible for an angle of a triangle? You bet it is. The fact that this is negative means that we are going to be talking about an obtuse angle here. Because when is the cosine possibly negative? It's going to be negative when I'm over in the second quadrant here. Okay, so I can actually use my calculator to figure out one possible value of A. Possible value of A would be the inverse cosine of negative 0.341, which, according to Cortana, give me my thousands of dollars, arc cosine of negative 0.341 in degrees comes out to 109. I'm just going to round that to 110 degrees. It was like 109.9 degrees. Actually, I'll just say 109.9 degrees. Okay, so that is one possible value of A. Are there others? Are there other possible values? And the answer, it turns out, is no, because the only other possible angle in the unit circle that would have a cosine equal to negative 0.341, so the other possible angles on the unit circle are in, actually really just one other possible angle, is in quadrant 3. And quadrant 3 consists of angles that are greater than 180 degrees. And you can't have an angle greater than 180 degrees in a triangle. So this is actually the only possibility. Switch colors here. This 109.9 degrees is the only possible measure of an angle in a triangle that will give you a cosine of negative 0.341. So if you see cosine of A equals negative 0.341, and you get 109.9 degrees, you can take that to the bank. That's the only possible measure of that angle. It may be you run into an impossibility someplace else, but if there is an angle A, that's it. And in fact, if I give you cosine of A equal to some positive value, then this also leads to only one possible solution. One possible value of A, which is gotten by taking the inverse cosine of 0.872. Okay, so anyway, that was kind of an adventure there. We went through a lot of different cases at once. But the main idea is, if I give you the sine of something and I give you a value for that, we have to think really hard about what the possible values of that angle are. There's usually more than one. There's an acute one and an obtuse one. If I give you the cosine of an angle, that usually leads to just one possible value. Unless it's an impossible value, like cosine of A equals like 2.78. That would be too much. Your cosine couldn't be equal to that. Okay, so anyway, that's the main point of that video.